I'm going to be talking about how to fit a line to data. Suppose that in the real world we've collected some data with various variables, and we want to compare two of those variables and see if they're related to each other. The first step to do here is to graph the data. If we draw a graph, let's call the variables y and x, although they could be anything. Now we want to plot the points that we've collected. Say it looks kind of like this. Of course, when actually solving a problem like this, you'll need to plot each individual point by reading the numbers off of your data. Now, our goal here is to find a linear equation which matches this data so that each point is as close to the line as possible. A pretty good way of doing this is to select 2 points that represent the data fairly well, and then find the equation of the line which goes through those 2 points. Now, when I say represents the data fairly well, it's kind of ambiguous, so it's left up to your best judgment. For this data, let's say we take this point right here and that point right here. They're at opposite ends of the data, so they should form a nice line, and they also seem to be in the middle of clusters of points. So they're both about average. First point, let's call it A, is at about -3, -1, and the second point, let's call it B, is about 4, 4. Now, we learned before how to take these 2 points and make a line out of it. So the first step is to find the slope. The slope is going to be m equals y2 minus y1, so 4 minus -1 divided by x2 minus x1, which is 4 minus -3. Here we're taking -3 minus 1 to be the first point, and 4 to be the second point. If we evaluate this, we get 4 plus 1 over 4 plus 3, which is equal to 5/7 as our slope. Now we can use one point, say -3 minus 1, and the slope, m equals 5/7, to write out the equation of this line using point-slope form. In point-slope form, we have y minus y1 is equal to m times x minus x1. In this case, y1 is -1, so y plus 1 is equal to m, which is 5/7, times x minus x1, which is -3, so we get x plus 3. And this is the equation in point-slope form. Now we can actually simplify this into the more compact slope-intercept form. To do this, let's first subtract 1 from each side of the equation. So we have y is equal to 5/7 x plus 3 minus 1. Now we can use the distributive property to simplify 5/7 times x plus 3. This is just equal to 5/7 x plus 3 times 5/7 minus 1, which equals 5/7 x plus 15/7 minus 1, which is 7/7. 15 minus 7 is 8, so 5/7 x plus 8/7. Now we have the equation of our line, which goes through A and B. In fact, we can draw this line to see what it would look like. And as you can see, it fits our data pretty well. However, notice that if different people choose different points to do this method with, they'll get different equations for their lines. There actually is an objective way to find a line of best fit, and also a measure of how closely it approximates your data, but that's beyond the scope of this lesson.